Hi. Okay, third try getting this done in 5 minutes. A body was found at 10 a.m. in a warehouse with temperatures 40 degrees Fahrenheit. The medical examiner found the temperature of the body to be 66.9 degrees Fahrenheit. What's the time of death? Use Newton's law of cooling with K equals 0.1947. Okay, first we need to identify the variables, okay? There's a lot of variables in that very complicated equation. All but one are given in the story problem. So T of T means the temperature given a certain amount of time that has passed. Well, we don't know the certain amount of time, but we know that the temperature is 66.9. T of A means the ambient temperature. Ambient means stuff that's happening around your point of interest. If you heard birdies singing in the background of this video, that would be an ambient sound, but we're talking about ambient temperature. So that's the temperature at the warehouse, 40 degrees. T sub 0, that means T, the temperature of the thing, the body, at the start time. This is not given in the story problem. You're kind of supposed to know from health class, 98.6, okay? All right, T of A again, we already know that. E is a constant that our calculator knows. K, they told us in the story problem, is 0.1947. The only thing left is T, and T is what we're trying to figure out. T is going to tell us how many hours ago the temperature was 98.6, okay? So once we get T, we're going to have to subtract that from 10 o'clock to figure out what time the body was killed. Okay, so we're going to throw all that into that big complicated equation. T of T is 66.9. T sub A is 40 plus 98.6 minus 40 times e to the negative 0.1947 times t. Okay? So the things that we can do right off the bat, kind of just arithmetic things, are I can subtract 40 from both sides. Okay, because it's a constant, so it's out of here. And I can simplify in this parentheses, so 98.6 minus 40 would be 58.6. Oh, yeah, 58.6 times e to the negative 0.1947t. Okay, this is kind of one thing. This is e to the power, so we can't split that up, but we can get rid of this 58.6 out there because that's times this, right? So we're going to isolate the variable that has the exponent by dividing by the coefficient. 58.6. So let me come down here and grab my calculator. 56.9 divided by 58.6 is 0.9709, 0.971 when I round it. Okay, make sure I put my point here. All right, now I need to get t by itself, but it's up there in the exponent. So this is when we use the logs, okay? So I can say log, because I have to do the same thing to both sides, and I'm using the natural log because I've got e involved here, equals log of this side